All right, so let's talk about proportional relationships. We're going to start with some vocabulary. The vocabulary we have is an independent variable, a dependent variable, unit rate, which we've already talked about, and constant of proportionality. An independent variable is a variable whose value determines the value of other variables. A variable whose value determines the value of other variables. And we use X to represent independent variables. A dependent variable is a variable whose value depends upon the independent variable. And we use Y to represent the dependent variable. So the dependent variable depends on the independent variable, which means the dependent variable changes based off of what you use for the independent variable. So unit rate we've already talked about in this unit. It is a ratio or a rate with a denominator of 1. Such as how many miles per gallon, how many miles in 1 hour, how much is 1 pound. It's when you're looking for a unit of 1. And our last vocabulary word is constant of proportionality. Constant of proportionality is the constant value of the ratio of two proportional means equal quantities, X and Y. And we use the variable K to represent the constant. All right, so when we talk about proportional relationships, they can be represented in multiple ways. We can use tables, equations, and graphs to identify if a relationship between two quantities are proportional. So let's look at example 1. Olivia always charges the same rate for babysitting. On Saturday, she earned $30 in 5 hours. Represent the relationship as a table, equation, and graph. So the first thing we need to do is figure out what two variables are being compared. We're talking about money and we're talking about hours. So our two variables are money and hours. The independent variable is the variable or the unit that doesn't change based off of what you plug in for something else. So when we're talking about hours and money, Olivia can choose to work as many hours as she wants to. But how much she gets paid depends on how many hours that she works. So when you have a job, you don't work the hours based on how much money your check is. Your check amount depends on how many hours you work that week if you have an hourly job. So for Olivia, when she's babysitting, if her money depends on the hours she works, then the hours is the independent variable and the money is the dependent variable. And now we're going to find the unit rate. So what we talked about previously in this unit is unit rate is when you want one of something. We want to know how much she earns, how much money she earns in 1 hour. So we're going to divide money divided by hours. And 30 divided by 5 is 6. So Olivia earns $6 per hour. That means $6 in 1 hour. Olivia always charges the same rate for babysitting. On Saturday, she earned $30 in 5 hours. Represent the relationship as a table, equation, and graph. So all we've done so far is identify the unit rate. So now we're going to talk about, is this proportional? So on top, I'm going to put hours. And on bottom, I'm going to put money. So I've got X and I have Y. So if Olivia works 0 hours, she gets paid $0. If Olivia works 1 hour, she gets paid $6. That's how we found our unit rate. That's how we know that for 1 hour, she gets paid $6. So for 2 hours, she's going to make $12. For 3 hours, she's going to earn $18. For 4 hours, she will earn $24. And for 5 hours, she will earn $30. So when we are identifying the constant of proportionality, when we're looking at a table, we're going to divide Y over X. So Y over X, you can pick any of the inputs and outputs on this table, any of the independent and dependent variables that we've plugged in to this table. So we could do 6 divided by 1, that's 6. 12 divided by 2, that's 6. 18 divided by 3, that's 6. No matter which one you pick for this, you're going to get that the constant, or K, equals 6. So that's how you can identify if a table is proportional, because every set that you divide is going to give you the same answer. Now, obviously, 0 divided by 0 is 0. Well, you can't divide that because you can't divide by 0. So the 0 input doesn't count. You go to the next one and then see, am I getting the same thing each time? If so, then that is proportional. All right, so let's talk about it in terms of a graph. So for a graph, you always put X, or the independent variable, on bottom. You put your dependent variable on the Y-axis. This is the X-axis. Up and down is the Y-axis. We're going to make our numbers at the bottom of the graph. Make sure you're going in. I'm skipping every other line and going up by 1 so that it's even. And I'm going to do the same thing on this side, going up by 6s. So we graph this from the table that we just created. At 0 hours, she earns $0. For 1 hour, she earns $6. For 2 hours, she earns $12. For 3 hours, she earns $18. For 4 hours, she earns $24. And for 5 hours, she earns $30. So when I graph this and connect my dots, you know that it is proportional if it is a straight line and if it passes through the origin 0, 0. To find a constant on a graph, you go to where x is 1 and look for what y is. K is 6. So I know we're saying the same answer over and over, but I'm just showing you how you can find the constant of proportionality using a table, a graph, and an equation. So for an equation, it is always going to be y equals kx. Y equals the constant times x. So dependent variable is y equals the constant, and we've said for all of these that we've done so far that the constant is 6, times the independent variable. Anytime you have an equation, the coefficient of x, that is your constant of proportionality. All right, so we've used the table, graph, and equation to determine that the constant of proportionality equals 6. K equals 6. And so how does the constant of proportionality compare with unit rate? They are the same thing. They are the same thing.